examples for calculating the force of gravity since I'm not here in class today, and this is something new that we haven't really done before. So, first thing, the force of gravity is always measured in newtons. So if you have an object and there's a force of gravity acting on it, and say it's equal to 100, that will always be measured in newtons. And in fact, all forces are always in newtons. All right, so just remember that anytime you get a number for the force of gravity or any other force, it will be measured in newtons, and it is important that you write that out, that it is N for newtons. So whatever it is, if you have a force of gravity that is equal to 10, it's not just 10, it has to be 10 newtons. All right, so newtons will always be what force of gravity or any other force is measured in. Second, to do calculations, mass must always be in kilograms. So if you have a mass that is equal to 5 kilograms, check, you're good. All right, now sometimes, like our scales that we use in labs and stuff, don't record in kilograms, they record in grams. So if you put something on the scale in our class, it would say, okay, that mass is 250 grams. Well, if you're going to use the equation, the force of gravity equals mass times little g, this mass has to be in kilograms, has to be. Otherwise, you'll get an incorrect number. Okay? Now, you can convert mass in grams to mass in kilograms simply by dividing by 1,000, because there are 1,000 grams in every kilogram. So a mass of 250 grams is the same thing as 0.250 kilograms. Something else you can do is literally put into Google 250 grams to kilograms, and that will convert it for you as well if you need to do that. Or Siri will do it for you, or Google will do it for you, or whatever else. Just make sure you're converting by dividing grams by 1,000 before you calculate. Otherwise, your numbers will be off for the force of gravity. All right, they'll be like 1,000 times too big, and that obviously will leave you way off what the actual answer will be. So mass must always be in kilograms and not grams. 3, little g is always 10 newtons per kilogram. So with the equation, force of gravity equals mass times little g, anytime you see that little g, you can automatically just be like, okay, that is 10 newtons per kilogram, which means if I know what my mass is, all I have to do is multiply that by 10, as long as the mass is in kilograms already. All right, so just remember that little g is always 10 newtons per kilogram. In this equation, we use little g as a symbol for the strength of Earth's gravitational field, but it will always be 10 newtons per kilogram. I should say it will always be 10 newtons per kilogram on Earth, but since that's where we live and do all of our work, that will be true almost all the time. Maybe we'll do some examples where like something is on the moon or something, but little g is always 10 newtons per kilogram on Earth. So a couple quick examples. All right, so let's say we have a box and it's sitting on the table, and this box has a mass of, let's say, 7 kilograms. Ooh, that didn't come through very well. All right, a force diagram for this, if it's just sitting motionless on a table, you're going to have a force of gravity that acts straight down. All right, and that is on the box by the Earth. And you will have pointing up, because the box is sitting on the ground, you will have a normal force on the box by the ground, we'll say. Okay, and those two forces have to be equal to each other. All right, so if we want to know how big the force of gravity is, again, force of gravity equals mass in kilograms times little g. We know here that this mass equals 7 kilograms. That's what it is. So we can do, okay, force of gravity equals 7 kilograms times the little g, which is always 10 newtons per kilogram. And then the force of gravity will be 70. And again, the units for force are always newtons. So the force of gravity is 70 newtons. So you can put that on the force diagram there. It's equal to 70 newtons. Now, we drew the force diagram and the equality shapes so we can see that the normal force and the force of gravity are the same size. So right away you know that, hey, this normal force, that also has to be 70 newtons because those are balanced and they have to be the same. Okay, let's look at a little different example. Let's say you have a force sensor and you hang a mass from this force sensor, but you don't know how much mass this mass has. But your force sensor tells you that the force of gravity acting on the mass is, well, let's not do that. That's the same thing. Let's see, the force of gravity acting on this mass is 95 newtons. Okay? What is the mass? All right. So again, we have this equation, force of gravity equals mass times little g. All right, but now we want to find the mass. So we can rearrange this equation to solve for the mass. We just have mass by itself on one side. So to do that, and this is going back to some math that you've probably done at some point before, I want to divide both sides by little g. All right, and then little g cancels out on the right side because little g over little g is equal to 1. And we're ended up with the force of gravity divided by little g equals the mass. All right, so now we have that, and we know what the force of gravity is. We know what little g is because that is always 10 newtons per kilogram. So I can just do 95 newtons divided by 10 newtons for every kilogram, and I get a mass that is equal to 9.5 kilograms. And that would be the mass for the weight of something that is 95 newtons. All right? So you can find the mass if you know the force of gravity because we know what little g is, and the only thing we don't know in this equation then is the mass. So that's an overview basically of the types of problems that we'll do. Again, super quick review. Force is always measured in newtons. So anytime you get a force, it'll be in newtons. Masses must always be in kilograms. To go from grams to kilograms, you divide by 1,000. Little g is always 10 newtons per kilogram. So if you see little g in the equation, you know what that is. It's 10. And that's it. Have a good day, everybody.